Hi everyone. Today we're going to see a topic called asynchronous counter. Asynchronous counter. Previously we have seen counters. What is the purpose of counters? Everything. Asynchronous. We know that there is a two major classifications in counters. One is synchronous counter. Another one is asynchronous counter. So what is asynchronous counter? Asynchronous counter will be having elements. So each element will be having different clock frequencies. So that kind of counter is called asynchronous counter. We previously have seen that counters will be having an memory elements or flip-flops. Okay, so here we are going to see only flip-flop based designs. Okay, so today we are going to see about asynchronous up counter, which is also called as a ripple up counter. So this has been designed using a JK flip flop. So how many JK flip flops we are having? We are having three JK flip flops. That means this is nothing but a 3-bit up counter. Okay, so that means it starts counting from 000 001 up to 111. So this concept you should be familiar with. Okay, so here input is x. X is the input. When x is becoming 1, the counter will starts counting. Okay, and one more thing here you can see in JK we have connected J and K combinedly. Every JK you have connected J and K combinedly. And then one more another information what you have to see was clock pulse. Okay, so clock pulse for every flip flop has been given. For the first flip flop a separate clock pulse has been given, and for the second flip flop the clock pulse is taken from the output of the first flip flop. Okay, same thing for third flip flop, the clock pulse has been taken from the output of the second flip flop. Okay, so this is how it has been connected. So another information was NOT gate. So every clock pulse has been sent to NOT gate. After that, it has been given as an input. Okay, so that means we are inverting the clock pulses. What this represents was the flip flop will active whenever a negative edge occurred in the clock pulse. For example, this is your clock signal. Okay, so negative edge means it starts from 1 to 1010. Likewise, whenever a transition occurs from 1 to 0, the flip flop starts producing the output. Every transition from 1 to 0, the flip flop starts producing the output. This is called as a negative edge triggered flip flop or negative edge triggered clock pulse. Okay, so first we will see the working operation of the circuit, then we will come and see about the outcomes. So this is our output, that means this is our circuit. Okay, so I have connected a clock, same circuit what we have seen previously. I have connected here. Okay, so now I am starting, I am giving an input. Okay, until the input is given the output is 0 only. If input is 0, for every clock pulse the output is 0. That means all are 000 only. That means the counter has not started counting. I'm giving an input as a 1 right now. Now we can see the counter starts counting. Okay, incrementation has been occurred here. Okay, can you able to see this? So this is how our working process works. I am going to explain you with respective of this timing diagram or waveform diagram also. So coming back to here, so we have seen how the according to the clock pulse how the counting works. Okay, as I told you, the flip flop will start producing the output whenever there is a negative edge occurs. That means 1 to 0 transition occurs. So we can see the clock has been given as an input to first flip flop, right? So one more thing what you have to know was this Q2 is MSB. Since this is a 3-bit counter, this is MSB and this is LSB. That means in this case this is Q2 Q1 and Q0. Okay, this is how it works. So as I told you, the clock has been given input to a first flip flop. That means Q0 flip flop. Okay, and then Q1 flip flop will get the clock as an input of as an input from the output of first flip flop. Okay, so we will see one by one. See here, whenever there is a negative transition occurs, Q0 starts producing the output. So initially the output of this is 0. Okay, so when this negative edge occurs, it started producing the output as 1. That means it toggles. Okay, when both are 1 in JK, the output will automatically toggles. Okay, Q bar will come into picture, right? QN bar will come into picture. That's why it is toggling. Okay, next 1 to 0 transition occurs, the output becomes again toggling. Previously it was 1, now it has become 0. Again 1, 1, 0, 0, 1, 1. See, for every each and every negative edge, the Q1 is started producing the output. Yes, okay. So this is the output of Q naught. Okay, Q naught. Now, what about Q1? So for Q1, the clock pulse is nothing but a Q naught signal only. So now assume this is another clock pulse for Q1. Okay. So as I told you, whenever there is a negative transition comes, 1 to 0 transition comes, the flip flop starts producing the output. So in this case, when Q naught is becoming 1 to 0, the Q1 starts producing the output. So until then it is having value of 0, 0. After that it will be having 1, 1, 1. That means it is toggling up to next 1 to 0 transition. When next 1 to 0 transition occurs, it starts producing the output as like this. Okay. Again for the next this one. Okay. Sorry, this is 1, 1, 1, 1. Okay, you understood how it is working like this. Next for Q2. For Q2, which is the clock pulse? For Q2, the clock pulse is Q1. So until the negative edge transition occurs, it is maintaining the value 0, 0, 0, 0, 0. When the negative transition occurred in Q1, it starts producing the output. Yes, until again another negative transition occurs. Okay, here another negative transition occurs. So this is how it works. So you can see initially 0, 0, 0, next 0, 0, 1. Okay, next 0, 1, 0, these two. Okay, next 0, 1, 1, these two. Next 1, 0, 0, these two, and then 1, 0, 1. You can see next 1, 1, 0. Okay, next 1, 1, 1, 1. The counting has been done up to starting from 0 to 1, 1, 1. Okay, so after that what will happen, the counting will go back to 0, 0, 0, and again it will goes on. Okay, so this is how up counter, that means asynchronous ripple up counter will work. Okay, so we can see the table also. So here you can see the table, wherever there is a clock pulse is 0. Okay, wherever the clock pulse is 0, you can see the changes in Q1. Okay, whenever a Q1 becomes 0, that means Q0 becomes 0. Okay, you can see the changes in Q1 also. Okay, 0, Q1 becomes 1. Again 0, it becomes 0. Likewise it goes on. Okay, so that's all for from this topic. We will see in the next topic.